Exercise 10 equation number 1. Two particles, one is 2 kg and 8 kg. The particle, this is 2 kg and this is 8 kg. So they name this is P particle, and this is Q particle, and connected with the light string, inextensible, and a force is given to go away for this side, and when it's taut you have a tension T, and this kept on a smooth plane. So since this is a smooth, there is no friction. So this is going to be weight of this particle 2g, and since it is touched, these two, when two surfaces touch, there's a normal reaction create perpendicular to the surface. I will take this is R1 and this is 8g and this is R2, and yeah, that's all. The first question is find the value of okay, this system is moving with 0.4 ms minus 2 acceleration. So we need to find the value of F. We need to find this force. So I know that when I compare whole system, so I can void this tension. So for whole system, I put F equal ma to this direction. F is, so now what are the forces? I can see F, and there is no any other friction forces, and now M. So in that case it is the total M. So this is going to be 2 plus 8, 10. Alright, it is 2 plus 8, and acceleration is given 0.4. So 10 times 0.4. So this is going to be Newton 4. The other option is we have to consider separately. So we'll work separately. Consider Q particle. So F equal ma when we put here for this particle. So we have only right side T, and there is no other forces, and weight is 2 and it is moving with 0.4. So then this is going to be 0.8 Newton. Oh, without solving, we'll stay with that. This is one equation 1. So tension we can take already, and this is consider particle P. If equal ma when we put to this direction, we can see there are two forces. R2 is horizontal, vertical, we don't need that. So only we consider horizontal forces, two forces, one is F, other one is T, F minus T, equal, this is 8 weight, and A is still 0.4. This is the second one. Now you can see when you add 1 and 2, 1 plus 2, this is cancel out. Okay, T plus F minus T equal 2 times 0.4 plus 8 times 0.4. This is going to be, so minus T to plus T cancel out. So F is remaining. So this answer is going to be 4 Newton. This is 0.8 and this is 3.2, and answer is 4 Newton. So when you consider whole the system, as I said, the T is, you will not get T, and you can straight find the F, or F is given, then you can find the acceleration. Part B is find the tension of the string. So actually we work out already, but if you work this one first, then you are not doing in this way, then you work out and you get F. Now you want to find the tension, then you want to consider, you want to put F equal ma to either this one or this one. So when I look at this, is there are two forces there, but there is only one tension. So one force here, that is tension. So it is easy to put F equal ma to, or this one to, so for particle Q, so F equal ma to this direction. So T equal, this is the only, and M is 2, and A is 0.4, then answer is 0.8 Newton. So that is the tension. And they don't ask R1 and R2. If we need to find R1 and R2, what do? We want to put F equal ma to this direction. So then we will get for particle Q. Then R1 minus 2G equal M times. This is not flying nor sinking. Because of that, this is going to be 0. So R1 minus 2G equals 0, R equal 2G. Likewise, if we need to find R2, F equal ma to particle P. Then the this is R2, and this is the opposite direction. Because of that, that is minus. M is 8, and it is not flying nor sinking. So 8 times 0. So R2 8G equals 0. R2 equals 8G Newton. So G is 9.8. M is minus 2. Part C is explain the modeling assumption. This is as usual. Inextensible acceleration of mass is the same. Light tension is same throughout the length of the string, and the mass of the string is negligible. Question number 2. Two particles P and Q, mass 20 and mkg, are connected by a light inextensible rod. So this is not a string, this is a rod. Okay, so this is P and this is Q. P and Q. So 20 kg and mkg, and this is a rod. And the horizontal force of 60 Newton is applied to Q in direction towards P. So this is the 60 Newton force is applied towards P. Causing the move with the 2 ms. So then it is moving to this direction. So this is in a smooth horizontal plane. So no friction force since it is smooth. No friction force. And so since this is a rod, when you push this one, you will get a thrust. If it is a string, if you pull from a spring, it is a tension. Now it is a thrust. I will mark this as F, a different letter, F. And then question 1, find the mass of M of Q. So we need to find the mass. So it is clear that it is easy to work with without this F. Hence we need to consider whole system. Okay, and this is mkg, and this is Q particle. So this is the R2. This is 20 kg, and this is R1. Sometimes they don't need R1 and R2. Now for whole system, F equal MA, so it is moving to this direction with 2 meter per square second. So the A is 2. So we'll put to this direction because it is moving to this direction. So this is 60, and there is no other external force. Those are internal forces and M. So the total weight is M plus 20 or 20 plus M, and acceleration is 2. Then from this equation we can simplify. So 60 equal 40 plus 2M, 2M equal 20, M equal 10 kg. So now we know uh, M value. The next question is find the thrust. Now when we find the thrust, we have to consider separately. So which one I am going to consider, P or Q? I can see that P is this one is easy because there are two forces. This is single force, so then I will stay with P. For particle P, F equal ma to this direction. F is, we have thrust F. This is the only one we have. M is 20 and A is given, we know that 2. So A is 2, M is minus 2 this direction. So thrust is 40 Newton. Question number 3, also same type of sum. Two particle P and Q, mass 7 and 8. So this is P and this is Q. So I usually mark P and Q when so this is going to be R and tension and some forces and mg. So P has to be marked either here, here, here or here, but it is better to mark one of this one. This is my ethics, but you can do the way you want. So height in inextensible wire. So this is in a smooth plane. Smooth, we don't need to write. So no friction. And this was 30 Newton is applied to Q. So 30 Newton is applied to Q. The direction away from P, this is 30 Newton. So it has a weight 7 kg and 8 kg, and this has a tension, and this is touched to this surface. So then there should be R normal reaction, R1 and R2, and this is T and this is T tension. Find the acceleration of the system. So we'll consider whole system. Consider whole system. Then this internal force is cancelling out. F equal ma to this direction. So this is going to be 30 equal m times. Now total m is 7 plus 8. And acceleration we need to find. So it should move to this direction. And it's not flying or sinking. On this direction only. Then A. So 30 equal 15A. A equal 2 ms minus 2. Now we need to find the tension of the string. So I'll stay with this one. Consider P. So F equal ma to this direction. So T equal, there is no other force, horizontal force for this system. And weight is 7. And acceleration, we know it is going to be A equal to ms minus 2, we found out. So this is, so tension is 14 Newton. Question number 4. Two boxes A and B, mass 100 kg, 9 sit on the floor with the lift. So this is a lift, and this is the cable, so it should have a tension. And this is the mass 1700 g is the mass of the lift, and also there is a weight of this is 190 and this is 110. This is A and this is B. Uh, so there is acceleration onto this side is 1.8. Now we need to find find the tension of the cable. So when you look at the tension, this is the only external force we can see. Sorry, this is the, in this way, this is the tension. Um, we will consider whole system, and we'll consider whole system, and we'll put F equal ma to downward. We'll take this word is positive, and so F. So what are the forces? There are two forces. One is actually T tension, that is minus T, and the weight. So this is 190. Because of that, we will get 190 G, and this is 110 G. So the total weight, this lift feel the weight of box A and B, and on top of the weight of the lift. So the total weight is going to be, okay, 110 G, 190 G, and 1700 G equal M. M is the total weight. Total weight is going to be 110, 190 plus 1700 times A is acceleration 1.8. So this is minus T, 2000 G, this is equal, this is going to be 2000 times 1.8. So T equal, so I'll bring T to other side, 2000 G minus 2000 times 1.8, I'll bring to left. So this is going to be 2000 times 9.8 minus 2000 times 1.8. This is going to be 2000 times 9.8 minus 1.8, because this is so same 8. So this is going to be 16,000 Newton. Now for the next question, we have to uh, show the internal forces. So I will rework this one. So this is 1700 G weight, and this is one box. So I'll keep distance so you can see, and this is the other box. Now we can see that this one is touching. So because of that, we will give the surface give R or S force to upward, and we will give a down S to downward on this one. And so this box has weight. So this is B. So it has 190 G. And then there is a, so those two touch together. Those two box touch together. Because of that, there is a force upward, that is, let's say R, and this A has a weight, so that weight is 110 G. So now this is tension T. Already we know 10 T is 1600. Okay, it's depend on, okay, 600 Newton, 16,000 Newton. Now we need to find R and S, and according, so there is a R belongs to here as well. So if we consider this one, so I can write like this. So this box A, this is 110 G, and there is a normal force called R. So this is this system. So this is it has acceleration of A to 1.8 towards downward. So if we consider this system, F equal ma to downward, then this force is 110 G equal m, 110 times 9 point A is 1.8. So plus this is minus R, because two forces, this is upward, we are putting downward, so minus R. So R is 110 G minus 110 times 1.8. So 110 times 9.8, so 110 times 1.8. So this is going to be 110 times 8. Actually, I will solve these two together to show something. So this is 880 Newton. Now this is a good example. What happened in your lift? So what is the actual weight of this one? The weight of this A is 7078 Newton. But you really feel it, that 880 Newton. It is 198 less than the weight. That's why when you are in a lift, sometime when it's go down, you feel that you will become light. Your weight is getting less. So this is the reason for it. Now this is 1.8. What will happen if we make this to 9.8? So R, so this, then R value becomes 0. R you will get because of a weight. Then it's like you are in a space if you bring to 9.8 speed. Next one, we need to find S. Now we know R is 889. Now we need to find S. S we can find two ways. Either you consider this system or just the lift. So we'll work both ways. So this is B. It has weight 190 G, and also it has another force, that is R 880. We know R value, that is 880 Newton. and there is another value go through S. So we need to find S. S is upward, both to downward. That's fine. Now it is moving down with 1 point ms minus 2. So F equal ma to downward, then you will get S minus 190G minus R equal, so R equal M is 190 times 1.8. So S equal 190G plus, no, this is wrong. So this is negative, this is positive, and this is positive because we are putting downwards. So those are positive and this is negative. Now it's right. Uh, now S is will bring to other side and this one to here. So 190G plus R minus 190 times 1.8. So 190 times 9.8 plus R, we found out 880 minus 190 times 1.8. When you consider these two, you can see that on this one also 190 times 9.8 minus 1.8, which is 8 plus 880. This much amount is, this is the weight of this one, this particle B, but it is the weight will feel when it is coming down just much of less. So that is 2400 Newton. Now the same thing we can consider this one and will work out with this one. When you consider this lift, so this is T is there and you have S here 1700 G, the weight of the lift. So F equal ma, so actually it has to be work in the same place, S and 1700 same line, otherwise it will rotate. F equal ma downward, S plus 1700G minus T equal M is now 1700 times 9, acceleration is A equal 1.8. So this is going to be 1.8. So then T S equal 1700 times 1.8 plus T minus 1700 G. So 1700 times 1.8 T, we know that is 16,000, and 1700 times 9.8. So you will get the answer, same answer, 2000. So you can work out two ways. You can see that when you give R upward, this person give R upward, he will get R backward according to the Newton law. And here also this person give a burden to this one S, then he will get it back as well S. Now it is balance. So when you consider whole system, so you can't see that. So you can only see that the externals, this one and the forces, the weight. Question number 5. A lorry of mass mkg towing a trailer of 3. So trailer is 3m, and this is m with a straight rod. The lorry trailer connected the inextensible tow bar. Okay. And the lorry exert in a driving force of 50,000 Newton. There's external force of 50,000 Newton. And it's accelerated with 5 ms minus 2 acceleration. and there's a resistance. It means this is okay. This surface is rough. So then I'll mark this is weight. So this is it usually look like, but I will keep a big gap on this one like this. Now we have a weight on this one. Weight is 3 mg, and this one touch now. So because of that, this ball has a resistance force R1, and the same to the this one we don't consider, and this is mg. So since those two are touching, so there is a above R2 force, and this is the R2 force to the uh, surface, and it is tau in, so it has a tension T. And now there is a resistance. I can see 4,000 and 10,000. So basically we mark resistance like this. So I will mark resistance to here. So 4,000 Newton, and this is 10,000 Newton. So this is the resistance force. Now I'm going to delete this one because we are not interested on this surface. So now we have the system, and if I put a dotted line, so this is the surface. So now we need to find the mass of the lorry and the trailer. So then best thing is when we consider whole setup, we can and if we put F equal ma to here, so then this t cancel out because we are considering the whole setup. If we put F equal ma to upward whole setup, you can get R1 plus R2 equal minus 3 mg minus mg equal 3m plus 3 4m times it's not sinking nor going up 0. So R1 plus R2 equal, this is going to be 4 mg. So we don't need this one yet. We consider whole system, and we will only put to the moving direction. So consider whole system. We put ma to this direction. Then the perpendicular ones are dropped. So F. So what are the forces? 150,000 is here, and then there is a resistance forces 10,000, and other 4,000 resistance forces to other way around, and the weight is total weight is 4m. So m plus 3m 4m, and the speed is 5 acceleration. So this is going to be 40,000, 36,000 equal 20 m. So this is cancel out and divide by 2,800 m. So lorry m equal 1,800, and the trailer 3m equal 3 times 1,800. So sorry, this is 5,400 kg. The next question is we need to find the tension. So we can simply consider this setup, and the trailer, for trailer F equal ma, when you put here only T minus 4,000 equal 3m. 3m value is what now? 5400. The weight is 5400 times 5. So T equal 4000 plus 5400 times 5. I think there's a small error in this one. This is still right. This 10,000 is should be have into here because that is the heavy one. And this is 4000 is the when it is heavy more resistant. So then this is T minus 10,000. This is 10,000 and you will get answer is 37,000 Newton. So next part C is explain the assumptions, modeling assumptions, light and inextensible. So question number 1, part C. So the same answer is the for this one. Question number 6. Two particles AB masses 10 and 5 kg respectively are connected by line. Particle B is hung directly below particle A. So this is A and B. So A is 10 kg. This is 5 kg. And a force of 100 applied for vertically upwards particle to accelerate. So this is 180 Newton. So we need to find the acceleration. So this is 10 kg. This is A. 10 kg. Particle B 5 kg. And it has now tension. And on top of that it has weight. So this is 5g. And this is going to be 10g. So this is T and T and 180 Newton force to upward and 5g downwards. So if we equal MA, we'll consider whole setup upward. Then the internal force is cancelling out. We can see 180 upward, and if you write T, you will see that plus T and minus T, and on the spot it is cancelling out. So we don't need to write. So 180 and consider whole system. And this weight is 10g and this is 5g equal weight 10 plus 5 15, 10 plus 5 15 times acceleration A. So 180 minus this is 15g equal 15a. So 15g mean 9.8 over 15a. A equal 180 minus 15 times 9.8 divided by 15. So A is 2.2 ms minus 2. Now we know the acceleration, that is 2 ms minus 2. Now we need to find the tension. So I will pick up this one. Consider B. F equal ma to upward. F is T minus 5g equal 5. Weight is 5 times we found out acceleration upward 2.2 now. T equal 5g plus 5 times 2.2. This is 5 times 9.8 plus 5 times 2.2. And So this is 5.9.8, 10 and 11, 12. So 5 times 12, 60 Newton. So what I did here, I factorized 5. So 9.8 plus 2.2, that is 12. Question number 7. Two particles A and B, 6 and mg, they are connected by light insensible by particle B directly below. A force and upward. So this is the opposite of number 6. So acceleration is given. In number 6, we need to find the acceleration. Now acceleration is given, we need to find the mass. So this is tt. So this is moving 118 Newton, and this is given 6 6 particle A is 6 kg and particle B is m. So it has a weight of mg. So this has a weight of 6g, and this is tension and this is tension, and this is 100 right. Now consider whole system. So F equal ma to upward. So this is moving with the velocity is given 2 ms minus 2. So F, what are the external forces? You can see 118 upward. Then this is weight is 6g downward. This the weight of this particle mg downward, and T is the internal force we don't consider, and mass weight 6 plus m, and then A is going to be 2. Now we have to solve this equation. 118 minus 6 times 9.8 minus m times 9.8 equal 2 times 6 12 plus 2m. So then 118 6 times 9.8, this is minus 12, this is to other side, m times 9.8 plus 2m. So this is going to be 9, 10, 11.8 m. So m equal 118 minus 58.8 minus 12 divided by 11.8. So m equal, you will get 4 kg. Now we need to find the tension. So we can consider this one or this system. But there are two forces, 1, 2, 3 forces. Here only two forces. So I will stay with B. For particle B. F equal ma to upward. T minus mg equal m times A, we know that is 2. Now m found out 4. T times 4g equal 4 times 2. T equal 4g plus 4 times 2, 8. 4 times 9.8 plus 8, the tension is going to be 47.2. Question number 8. A train engine mass 6,400 is pulling carriage of mass 1,600. It's a train and carriage. The weight is 6,400 kg. Um, so it has a frictional force R2, and this weight is 1,600 kg. So 6,400 g. So 1,600 g, and weight is 1,600. So this is R1, and it has a tension and this one is pulling driving force with 12,000 Newton, and it has engine and carriage resistance force. So engine is R, and this one is 2000 Newton. So the first question is, so it has a 0.5 ms minus 2 acceleration. Everything is same. So given that the acceleration, find the r. So still we have to consider whole setup to this direction. Uh, then we only, the unknown is r. Consider whole system F equal ma to this direction. So what is the total forces? 12,000 to this direction. So this is force, this is one and this one. So this one is minus r and this one is minus 2000. Sorry, 2000, yes. And what is the total weight? So this is 1600 and this is 6400. So 1600 total mass, not the weight. Without g, 6400 times 0.5. Then this is going to be 12,000 minus 2000, 10,000 minus r equal 6,000, 8,000 times half. 8,000 times half mean 4,000. 10,000 minus r equal 4,000. So 10,000 minus 4,000 equal allowing. So R is 6,000 Newton. So the resistance force is 6,000 Newton. And now we need to find the tension. So that the tension of T. So we'll consider this one. F equal ma to this direction. So this is tension T minus 2000 equal mass 1600 times 0.5. So T equal 2000 plus 1600, half is 800. So T equal 2800 Newton tension. So this is carriage. Consider carriage. Question number 9. A car of mass 900 kg pulls a trailer of mass 300 kg along. So 900 and 300. So this is 900g and this is 300g. And 200 and 100. So resistance is 200 and this is 100 Newton, and there's a force of 1200. So as usual, so that the acceleration. So this is t and t, and we have to mark r1 and r2. So F equal ma to this direction for whole system. 1200 minus 200 Newton and 100 Newton equal M. So total weight is 300 plus 900 times A. So this is 900 equal 1300. 1200 A equal 9 over 12, which is 3 over 4, which is 0.5 SM minus 2. Now next one is find the tension. So as usual, we'll consider this one for 300 kg particle. F equal ma to this direction. F is T, and the resistant forces is 100, equal M is 300 grams, mass is 300 grams, and E found out 3 over 4. So then T equal 100 plus 300 divided by 475 times 3, 225. So this is 325 Newton. Now the car is moving along a traffic on a road. When the driver sees a set of traffic lights turn into red, he reduces the force, produce engine to zero, and brakes. The brake produces a force of car magnitude F Newton. So what will happen? What is happening when the driver sees a red lights? So take the accelerator out, then this will go zero, and apply a force to this direction, brake. So now same thing. So there is no force, and this apply a F to this direction. As a result, this tension become a thrust now. So we'll put T bar, and the resistance is still stay the same. So this is 100, and this is 200, and this is 300 G. And now T bar, instead of T bar, we'll put different symbol, T naught or simple T, simple F. Now we can consider this system, and the thrust is given, F value is given as 100 Newton. So we need to find this F. So first of all, we need to find the deceleration, because when you apply this system is decelerate. For that, we'll consider this particle, 300 G particle. Consider 300 G particle. F equal ma to this direction. So we can see that now the tension is 100, and the thrust minus F times M is 300 times A, and F we know that this is going to be 100 as well, it is given. So this is minus 200 equal 300 times A equal minus 200 over 300, which is minus 2 over 3. So acceleration is minus 2 over 3. Deceleration is 2 over 3. Now we need to find this one, so we can put F equal ma to this one. So then this is going to be minus F, capital F, and then 200 minus 200 resistance, and plus 100 equal M is 900 times the deceleration we work out, that is minus 2 over 3. So minus f, this is going to be minus 100 equal 900 divided by 3, 300 times 2 minus 600. Then minus f, I'll bring to other side f, and 600 to this side, 600 minus 100. So F equal 500 Newton. This 100 is F, this F. So this F is, we know it is 100.